Good morning, everyone. In this particular video lecture, we will discuss a new topic, that is solution of parallel circuit. Now, this is basically the method through which we can easily solve any, we can say, parallel RLC circuit. As you can see here, there are basically three methods. The first one is vector or phasor method. The second one is admittance method, and the third one is complex or phasor algebra method. Now, as you can see here, this is basically the circuit diagram for the first one, that is vector, or we can say phasor method. Now, as you can see here, in this basically given circuit, if you want to calculate the value of z1, then the value of z1 will be equal to r1 plus jxl, and the value of z2 will be equal to r2 minus jxc. Now, my dear friends, this is basically, we can say, branch A, and this is basically branch B, as you can see here. Now, for branch 1, if we want to calculate the value of current, then that will basically equal to, as you can see here, this is the value of impedance, and we know that the for the calculation of current, I is equal to V by impedance. And now here, the value of, we can say, the magnitude of impedance will be equal to root under r1 k square plus xl k square. So this will be the equivalent, we can say, the current across branch 1. Now, we will move to the next one, that is, as you can see here, for, we can say, branch 1, if you want to calculate the value of power factor, then it will basically comes out to be r1 by z1, which will be lagging in nature due to the presence of inductor in the branch. Now, for branch B, if you want to calculate the value of current, then that will basically equal to B by, we can say, root under r2 k square plus xc square. And if you want to calculate the value of power factor in for branch B, then that will basically equal to, we can say, cos phi 2 is equal to r2 by z2, and this will be basically leading in nature due to the presence of capacitor in branch B. Now, we will draw basically the phasor diagram. As you can see here, the first case will basically suppose that, basically, we know that in the given figure, basically there are two branch. The first one is basically A, and the second one is basically B. Now, my dear friends, for branch 1, let us suppose that the, we can say, the phasor angle is basically phi 1, and for branch 2, let us consider the phasor angle is basically phi 2. Now, keeping in both these points, we will draw basically the, we can say, the phasor diagram. As you can see here, both the element are parallel, so here we will take voltage as reference. Now, as you can see here, this is the basically voltage as reference. And now, in case of basically capacitor, or we can say, in case of basically, in case of branch basically B, as you can see here, basically, in the case of branch B, the circuit will be leading in nature, and in case of branch A, the circuit will be lagging in nature. So here in this, as you can see here, this is basically the current of branch 2, and this is basically the current of branch 1. This is basically the leading in nature, this is basically the lagging in nature. And after drawing I1 and I2, if you want to basically find out the equivalent, then that will be basically equal to I, as you can see here. So this will be basically the equivalent current I. Now, as we move further, then as you can see here, basically we will break this I2 and I1 into horizontal and vertical component, that is into X and Y component. Now, my dear friends, for I2, if you want to basically write the horizontal and vertical component, then first of all we have to draw a coordinate axis. And after drawing, this will basically the horizontal component, and it will be basically, we can say, I2 cos phi 2, cos phi 2. And if you want to basically write the sine component, then that will basically, my dear friends, equal to I2 cos phi 2. In the same way, we will basically write the x component and y component for for I1. And now that will basically equals to, as you can see here, as you can see in the next diagram, we have basically break the I1 and I2 into X and into its X and Y component, or we can say into horizontal and vertical component. Now, if you as you can see here, this is basically I2, and the value of I2 along the x-axis is I2 cos phi 2, and the value of I2 along the y-axis is basically I2 sin phi 2. In the same way, my dear friends, we have also break the I1 component into its x and y component. As you can see here, its x component is equal to, we can say, I1 cos phi 1, and its y component is equal to I1 sin phi 1. Now, we will basically discuss the next diagram. As you can see here, this is basically the next diagram. Now, my dear friends, basically we have taken all the x component along this side, we have taken all the x component along this side and all the y component along this side, and as we will take all the x component and y component, this will be basically our equivalent current I, we can say. Now my dear friends, from this we can easily basically calculate the value of I, as you can see here, by using, we can say, the Pythagoras theorem. The value of I will be root under x component square plus y component square, and after putting all these value we will get the value of I equal to this. And my dear friends, if you want to calculate the value of tan phi, then it will basically y component by x component, and its value will basically comes out to be something like this. And if you want to calculate the value of power factor from here, then we can easily calculate by which will be equal to x component by I. Now my dear friends, we will discuss the next method, that is admittance method. Now in admittance method, my dear friends, we as we know that z is equal to r plus jxl. Now my dear friends, if you want to, we also know that admittance, that is y is equal to 1 by z, and if we equate these equation, then y will be equal to 1 by z, and 1 by z is equal to 1 by r plus jxl. And if we rationalize these values, then it will be basically comes out to be, as you can see here, y means admittance is equal to r by r square plus xl square minus jxl by r square plus xl square. Now as you can see here, this is basically the impedance triangle which we already have discussed in the previous lecture. This is basically the resistive component, this is basically the inductive component, and this is basically the overall, we can say, impedance. Now my dear friend, this is the impedance triangle, and this is basically the, we can say, admittance triangle. And from both these from this impedance triangle, if you want to calculate the value of r, then that will basically equal to r cos theta, and if you want to calculate the value of xl, that is we can say inductive reactance, then it will be basically equal to z sin phi, as you can see here. Now my dear friends, from this admittance triangle, if you want to draw the value of basically g, then that will be basically equal to y cos phi, and if you want to basically calculate the value of b, then it will basically equal to y sin phi. Now my dear friends, as we move further, then as you can see here, y is equal g is equal to conductance is equal to y into cos phi, and cos phi from admittance triangle, it will be equal to r by z. So the overall value will be comes out to be r by z square. In the same way, we will basically calculate the value of b, that is susceptance, we can say, and the value of b will be equal to xl by r square plus xl square, as you can see here, and the value of this will be the value of g. And if you want to calculate the value of y, then it will basically equals to root under g square plus bl square, and the value of power factor will be g by y. So this was all regarding the, basically, we can say, the admittance method. Now as you can see here, my dear friends, as we know, this is basically the as we know that basically there are two types of susceptance. The first one is inductive susceptance, and the second one is capacitive susceptance. Now from this triangle, my dear friends, as you can see here, from this triangle, if you want to calculate the value of tan phi, then it will basically equal to b by g, and the value of phi will be equal to tan inverse b by g. Now my dear friends, as you can see here, this is basically the inductive susceptance, and its value will be equal to 1 by jxl. And if we send j above, or if we multiply numerator and denominator both by j, then the whole equation will be equal to minus j by xl, or we can say 1 by xl at angle minus 90 degree. And in the same case, if you want to calculate the value of capacitive susceptance, then it will basically equal to 1 by minus jxc, and if we send j above, then it will basically becomes positive, and the whole equation will be equal to 1 by xc at the rate angle 90 degree. Now my dear friends, we will discuss the next topic, that is complex or phasor algebra. Now this is the basically last method for the calculation of parallel RLC circuit. Now as you can see here, my dear friends, this is basically the circuit diagram, and from here z1 will be equal to r1 plus xl1, and from here you can see z2 is equal to r2 plus xl2. Now my dear friends, the next thing, as you can see here, and from this circuit diagram, the value of z1 will be r1 plus jxl, and the value of z2 will be equal to r2 minus jxc. Now as you can see here, as we move further, Then for figure 1, that is we can say for this figure, as you can see here, I1 will be equal to V by Z1, and I2 will be equal to V by Z2, and the whole current will be equal to, my dear friends, I1 plus I2 means sum of individual current. And as you can see here, as we put the value of I1 and I2, then our whole equation will be equal to I is equal to V into Y1 plus Y2. My dear friends, Y1 is equal to 1 by Z1, and this Y2 is equal to 1 by Z2, and the value of y1 plus y2 is equal to y net, as you can see here. So y net, we can so I will be equal to v into y net. Y is basically, we can say, my dear friends, admittance. Now in for if you want to calculate all these value for figure 2, then as you can see here, y1 will be equal to 1 by z1, and it will basically equal to 1 by r1 plus jxl. And as we rationalize, then our whole equation will comes out to be g1 minus jb1. In the same way, my dear friends, if you want to calculate the value of y2, then our equation will be equal to g2 plus jb2. Now as we move further, then if you want to calculate the value of equivalent, we can say, admittance, then it will be equal to y is equal to y1 plus y2. And as we put all these value, then our then the magnitude of y will be equal to root under g1 plus g2 ka whole square plus b1 minus b2 ka whole square. And from here, my dear friends, we know that basically cos phi, that is power factor angle, is equal to g1 plus g2 by y, and phi is equal to tan inverse b1 minus b2 by, we can say, g1 plus g2 means we can say the imaginary part by real part. So my dear friends, based on all these method, we will basically discuss a numerical question to understand these methods. Now as you can see here, this is basically a numerical question. Two circuit of impedance of which are given by z1 is equal to 10 plus j 15, and z2 is equal to 6 minus j8. Now my dear friends, in ohm are connected in parallel. As you can see here, this is basically z1 and this is basically z2, and both these two are connected in parallel. If the total current supplied is 15 ampere, means, my dear friend, here the value of I means whole current is given, that is 15 ampere. And what is the power taken by each branch? Now we have to calculate the power taken by each branch, find also power factor of the individual circuit, and we have to basically find out the value of cos phi for individual circuit. And we also have to draw, we can say, vector diagram or phasor diagram. Now my dear friends, as you can see here, this is basically the circuit diagram, and z1 is equal to 10 plus j15, and z2 is equal to 6 minus j8, as you can see here. Now my dear friends, if you want to calculate, as we know, these both are in parallel, so if you want to calculate the z equivalent, then its value will be equal to z1 z2, as you can see here, by z1 plus z2. And as we put all these value, then our equation will basically comes out to be, as you can see here, after doing all these calculations, our equation will basically comes out to be z equivalent will be equal to 10.30 at the rate minus 20.45. Now my dear friends, as you can see here, the next thing, that is we will basically calculate the value of I. Now as we calculate, as we know that I is equal to V by Z equivalent. So if you want to calculate the supply voltage, then as we put all this value in this equation, then the value of voltage will be basically comes out to be 154.8 at the angle minus 25.5 degree. And in the same way, if you want to calculate the value of current through, we can say, impedance z1, then we will use this formula, and after using this formula, our basically current will be comes out to be 8.6 at the angle minus 76.75 degree. Now if you want to calculate the value of current through branch 2, then my dear friends, as you can see here, this is basically the value of current through branch 2, and it will basically equal to V by Z2, and its value will be equal to, we can say, 15.48 at the angle 32.6 degree. And now in the same way, if you want to calculate the value of power for we can say impedance z1, then it will basically equal to I square r1. And as we put all these value, then our equation will comes out to be the value of power will be equal to 737.881 watt, and P2 will be equal to basically 1437.7824 watt. Now my dear friends, if you want to draw the value of phasor diagram, then as you can see here, basically we will take current as a reference. And now as you can see here, I2 is basically we can say I2 is basically, my dear friends, we can say leading, and this one is basically our I1, which is basically lagging in nature. So my dear friends, this was all regarding the calculation of, we can say, parallel RLC circuit. I hope you have enjoyed this video. That's all. Thank you.